Hello everyone, my name is Masheka and this is my Module 4 Chapter 11 presentation. So let's get right into it. Okay, the first problem is Ephraim and Devontae were asked to reflect a pattern block figure shown on the left over the horizontal line through the center of the square. They rearranged the block form of the figure on the right. What type of rich motion did they use and how would you have corrected this misunderstanding? Okay, so this is the figure that we are given, and this is the figure that they had showed. Now, of course, this is wrong. So instead, it seemed that they had a 180 rotation instead of a reflection. So how can we clear out this misunderstanding? And there goes them. Okay, this is our figure that we start with. Now, when we do a reflection, when you usually do a reflection, it still points in the same direction. So using this meaning, will the triangle points from this section will still point to the right. So with this, we'll reflect it like water is the best way to explain it. So through the square, and we'll reflect it, which it'll be in the same direction. So the triangle will point in this direction, while the horizontal will be in the top. So reflecting through the square and still point in the same direction, it then we put our trapezoid. And that's how we correct the misunderstanding. Now, on this problem, it wants us to show which figure is one line of symmetry but no rotational symmetry. Now, what is a one line symmetry? A one line symmetry is something that can be divided in half and reflect on the other half. So, what figures would be able to be divided out of these figures? What would be able to be divided and have a reflection? One line symmetry, a reflection of itself that rotate. So, like I kind of mentioned earlier, a triangle is a major one because it'll be able to be divided in two, like these triangles. And when you fold it in half, it will have an exact mirror image at the other half. You also have this half circle, which divided in half, it will have the other half will be able to fit perfectly. It didn't have this pentagon. Now, what is a rotational symmetry but not a reflection symmetry? Now, this is already popped up, so we're going to just pull this up here. Now, a rotational symmetry is something that is able to rotate in 180 degrees and still be in the exact same spot or still look the same. So I had this on transaction. So when you rotate this figure, it'll have 180 and then it'll go back to 360. It'll do 360, but when it's do it halfway, it'll still have the same. So let's review. I cannot stop it, but whenever it stops in the middle, it will have the same section. Same with the next figure. That's 180 and it goes to the right, same shape, and now it's at 360. Now, what is one line symmetry and rotational symmetry? This is the figure that is able to have one line symmetry, which is be able to divide itself or fold into itself and have the exact mirror, and also be able to rotate and have the exact same shape or section. So the diamond have four lines of symmetry, and even rotated, no matter the 180 to the 360, it will still have the same shape, diamond shape. And then we have a rectangle, which is have four as well when you rotate it. One, two, three, four. And then back to its original section, as well as being able to rotate in 180 or 360 degrees and be in the same exact place. Now, our third question. Mara cut out a regular pentagon, hexagon, and octagon, and it seems to her that they form a vertex figure, such as the one shown to the right. Respond to Maya. So this is the figure that she has, and she said it's form a vertex figure. Now, what is a vertex figure? A vertex figure has a figure that adds up to 360. Now, interior angle equals 360. All shapes of the interior angle have to equal 360, which means the pentagon, the hexagon, and octagon will all have to equal 360. So now we have to find the interior angles of all shapes and then add them together to see if she's right. Now, the formula is n2 times 180 divided by n when n is the number of sides. So let's move this up here. So pentagon has 5 sides. So we'll plug in a 5 for n. So 5 minus 2 times 180 divided by 5 equals 180 degrees. Then we have an octagon, which is 8 sides. So 8 minus 2 times 180 divided by 8 equals 135 degrees. And then we have a hexagon, which is 6 minus 2 times 180 divided by 6 equals 260. We'll add them all together and get 363. This means that this is not an interior angle. Sorry. This is not a vertex figure. So what can we do to make this a vertex figure? Since it seems that it is 363, that means it is 3 degrees off. So what we can do is form a 3-degree space where this red triangle is. So it will form a interior vertex figure. Now, our fourth question. Demonstrate why the triangle QPT is congruent to SPT is true, and then QPT congruent angle QPT is congruent to SPT, and then triangle QPV is congruent to SPV, and angle QVP is a right angle. So demonstrate why QPV and PT and SPT is congruent. So these are the figures that we're talking about. So from right here, we are from a eye distance, we see that they are congruent. But to make this really congruent, you can say by the angles, they are congruent triangles, which means they are congruent, which means they have the same angles and size. So line PT is acting as a reflection. So if we fold the figure in half, these are perfect triangles and they will fit. Now let's go to angle QPT is congruent to SPT. And this is just like the first one. The shapes are congruent and they are congruent triangles. So this means their angles are congruent as well. Now let's go to triangle QPV is congruent to SPV. This is because line PV is acting as a line of symmetry as well. So when the object is folded in half, they match perfectly. Now our last, why is QVP is a right angle? Well, when a line is acting as a symmetry, it's acting as a symmetry, it's acting as a symmetry line of symmetry, there you go. It will 9 times out of 10 form a straight line and that'll make a 90-degree angle. So PV is a straight line and it's acting as a transaction to PVT and then QVS. So with these two lines, it'll make a right angle. That also means that PVS is a right angle as well. And there you go. I need to move that triangle over, but that's the idea. Now we need to find, in this problem 5, we need to find the angle NOQ. Now these are our square. We have a circle that inside of it is a pentagon, and then we have an equilateral triangle. And we need to find NOQ, which is this red triangle right here. So for a fact, we have a pentagon and an equilateral triangle. So to solve this, to To find this, you need the formula 360 divided by n, and n is the number of size of the shape. 360 because it's a side of a circle, and the circle is 360. So first let's find the penta. So we have PON, which is PON. So what we'll do is we have 360 divided by 5 because it is 5 sides equals 72. Now we have 72 times 2 equals 144. Now we'll do the equilateral triangle, which is PQR, and this is POQ. I'm sorry, POQ, which is our equilateral triangle. That red line is not in the right place. So we'll do 360 divided by 3 equals 120, and that is POQ is the center, so there's no need to divide. So now that we have our central angles, now we have to find the differences. So what we'll do is we'll do 144 minus 120, and we'll get 24 degrees. So NOQ is 24 degrees. Now our last question. We'll have to move this down here. This is the picture to show what is showing. We have a girl with the ruler and then a mountain. So we're going to have to actually move this so you'll be able to see. Now let's read the problem. The problem is by holding a ruler 2 feet in front of her eyes as illustrated in the diagram, Jenny sees that the top and bottom of the vertical cliff face line with the mark separated by 1.5 inch on the ruler. Jenny is now a quarter mile away from the cliff. What is the approximate height of the cliff? Recall that amount is 5,280 feet. Okay, to solve this, we'll need this formula. Distance from her eye, sorry about the R, over distance between ruler markings equals distance from cliff divided by height of cliff. So we'll just plug in from our problem that's given. So distance from her eye is 2 feet, which is the line right here. And then distance from ruler marker, which is 1.5 inch, which is right here. And then 1.5 miles, which is distance from the cliff. And then the height of cliff. So now that we have the formula, we'll have to flip it and rewrite. So now we'll have the height. What we'll do is we'll just flip it up and down and then move the sides. So we'll have height of cliff over on the left. So we have half of the cliff, which we don't know, which we're trying to find out, over 1.5 miles equals 1.5 inch, which is over here, over 2 feet. Sorry if I'm going a little too fast. So now we'll just have to convert everything to feet, so we'll all have one equal measurement. So again, we'll have the height of cliff, which we're looking for, and then we have 13.20 feet equals 0.125 feet over 2 feet. Now to get the height, we'll go ahead and move this up here. To get the height of cliff, we must get height of cliff by itself. So what this means is we're going to have to times everything by 1,320 feet. Sorry, I put the decimal. There's not a decimal there. So what we'll do is we'll multiply everything by 1,320, and then that's equals also over here. So we'll have 0.125 times 1,320, and then over 2 feet to give us the height of cliff equals 82.5 feet. And that's the end. Thank you for watching my presentation.